Hello everyone, can you hear me? Is my sound audible to all of you? Clearly audible or there is some disturbance? Okay, great. So today we are going to talk about these four different products which lie under Apache's which are related to Apache Hadoop. Okay. So these products are quite related to the big data analysis, and we will go one by one and talk about how and what do they do. First one is Scoop, other is Flume, Uzi and Mahat. Okay, Mahat will just touch the introduction part. Hands-on will not be able to give it today, but we will give the hands-on on Mahat later at later point of time. All right. So the way we are going to, I will go about all of these products is, we will not go too much deeper into each of the products. Instead, we will just show the use cases and a little bit of hands-on, and then you can take it forward. All right. Great, great. So now, so before I start, do you have any questions to me? Bhagwat, I have not been able to look at your pig script, and actually I'd been busy with fixing the cluster, and probably by Monday evening we'll have everything in place and in running. And what I noticed was that couple of services was down on the cluster. All we needed was to restart those services, and they are for, and I'll debug those services on Monday. All right. So okay. Hadoop 3 was also down. Is it? At a moment of time, I had restarted Hadoop 3. Okay. I had restarted Hadoop 3 for some time, and then maybe that time you accessed. So Hadoop 3 as in uh, you mean to say that complete server was down, or you were not able to use uh, a particular service like pig. So Anto Alex's question is that, do I have Ambari setup? Could you share those? Actually, we followed a particular documentation from Ambari, and that was sufficient. So I would share with you that particular URL, and then you can follow that one, and that should be sufficient for you. Okay. Basically, the way you set up Ambari is, you first of all set up only the Ambari server, and then you start installing Ambari agent on all the nodes. Okay, Ambari server and Ambari agent, once they are installed, you can start installing it using Ambari. You can start installing other tools. Okay, and you can move one tool like pig client from one machine to another based on your convenience. Okay, so I'll share with you though that wiki of setting up Ambari. All right. So for Suksavat, the pig on Hadoop 3 seems to work fine. That is why actually I'm doubtful. So, uh, Bhagavat, were you able to run the same pig script on your virtual machine? No? Okay, pig local works. Okay, 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 okay. No, Suksavat, if the your basically, how did you test your script using pig or pig minus x local? Okay, okay, okay. So probably the node is Hadoop node was down or HDFS node was down. Maybe that is the reason it is giving error. Okay. In such case, you log into you basically you say service and Hadoop restart or service HDFS restart. That should mostly be sufficient. Okay. In case of Hadoop 3, but in case of Hadoop 1 and Hadoop 2, they are on Ambari and they work really well. Okay. So, yeah. All right. So I'm starting now. Okay. So basic problem which we are facing right now is pig is basically pig in local mode is working fine, just that the HDFS mode is not working well. Okay. So that we need to look into. Okay. All right. Great. So now we have fine. Now we have got this. So Scoop is quite a simple system. It basically, instead of you writing your code to take out data from HDFS or HBase to and fro to a structured data store such as MySQL, Oracle, and all those kind of databases, it helps you by providing you upfront connectors and by providing you simple command line to do all of your job. Okay, so that is what Scoop is all about. Okay, so Scoop helps you moving data from database to HBase or HDFS and then move back the data from HDFS and HBase to the file system. So that's what a Scoop is all about. Okay, so it extracts the data from a structured data store into Hadoop for further processing and can also move data from database to HBase, as well as it can export the data back to the data store. And the very important aspect of Scoop is that it has got extension framework. If there is a if there is particular you can extend and add one more connector for your own database if it is not there already. Okay, so First of all, you can do an SSH onto Hadoop too. So Scoop is a client. Scoop is simply a client. It doesn't have a server-side component. All right, and so you can simply, that is why this client is only installed on one machine. It is not installed on all machines. You can SSH to Hadoop too and access it. And these are the various commands which Scoop provides you, starting with code generation. But most important, we will be going with this order. First one we'll talk about import, and then we'll talk about create hive table, and then code generation. Okay, and then we'll talk about export. Okay, so basically a scoop help gives you a further help also. If you say scoop help import, and that it will give you the more uh, details about each of the functions. Extremely sorry. Okay, and so this is the simple way to describe it. Okay, and it serves as a really good ETL tool for simple use cases, not like what Informatica and other people are providing you. Okay, so we'll go through it once. So a connector, a scoop connector is basically a modular component that uses an extension framework so that in case that connector is not available, in case you have a new database, you can implement a connector, and then you should be able to do in and out from the HDFS or HBase. Okay. Similarly, the available connectors right now are for MySQL, Postgres, Oracle, SQL Server, DB2. So for almost all of these, there are uh, connectors available. And on top of it, there is a generic JDBC connector. Any database, probably all the databases, including systems like Google's Bigtable, they all support JDBC. Okay. So if they have implemented JDBC connector, that means almost all the databases are covered for communicating with the HBase or HDFS. And there are third parties also which provide the connectors such as Neteja and Teradata. So I will go right and then start working on it. All my scripts worked on pig local. Are these only for RDBMS ones or NoSQL also? So these are only for the RDBMS mainly. Okay, and there would be a connector for MongoDB and Cassandra also. All right, and you should be able to do that using Hive. Okay, Hive helps you, but Hive does not let you write. So basically, you will have to figure a way out. I think let me have a look at scoop MongoDB import. Is it possible to read MongoDB data? Right. Actually, there are different projects which help you communicating with NoSQL and HBase or HDFS. Okay. Like Mongo Hadoop is there for MongoDB and Hadoop communication, and so on. All right. So, but this one is generally for the structured databases, the RDMS ones specifically. Okay. Now let me show you. So our objective first of all is say create a database table. So this is for creating a database, then create a database table, and then insert the data into that table. Okay. So then we'll have one our ready, basically pre-prepared pre-prepared database from which we can do a import. All right. So let me start with so before I move on, I will be switching to full screen mode. Okay, I think I will switch to full screen mode because that's what is required. Yes, yes, it is being recorded, right? Yeah. Thank you, Shashank. Thank you, Anto. And so let me share the full screen. All right. So searching Mac. So if I share the whole screen, all right. So Shashank, are you able to hear me clearly? Because you were not able to hear me clearly. Is anybody else having the problem with hearing? Because I need to check whether my connection is bad or something now. Kalyan, are you also not able to hear? Okay, okay. You mean to say there is no problem? All right. And so Shashank is, I think, probably going to disconnect and then connect. Great. Now let me SSH to the server. Okay. So this is my, after I have SSH'd onto Hadoop 2, here I am using a different account called root. Alright. And then I have also installed MySQL onto this. Okay. But MySQL is not installed as a daemon right now. So you might have to start it first. Okay. Yeah. It is now started. Now I can say MySQL and say so databases. Alright. Already we have created a database called Hadoop Guide, and we will just create a newer database called Hadoop class. Okay. Create database, and we call it scoop example, or we actually, for the convenience, I will just keep uh, create Hadoop class. Okay. Create database, not Hadoop. Let's say scoop example. Alright. So here the database is created. Now we can say, see, this we are talking about MySQL. Okay. Now I say use scoop. Right. So basically what we are trying to do is, in the local MySQL, we are trying to create some dummy data. Okay. And that means my example, I'll have to change the code accordingly. Okay. And yeah. Okay. Okay, done. Then I will say create a table called widgets, and now the table is created. Now the create a table um, which has some widget name, some ID, and some widget name, some price, and it has got some date and version. And here we go. Okay, so we can see that the widgets have been add it to the widgets table. So there are basically three rows with some data in it. Alright. Okay. And when we say null here, why we have done that? So that widgets can automatically, this MySQL can automatically create the ID for this table. Okay. So, do you have to be root to use MySQL? I can connect MySQL as a student, but not able to create a new table. Okay, so what you do is Bhagwat, you use my database, same database which I am talking about, because I've just created a database, and similarly you also, or you can create a database of your own first and then start using it. Alright, are you able to create a database using a student? Create database in your database name. Okay, okay. Then maybe you will have to use the database ScoopX, because I have given the privileges on ScoopX to everybody. Now everybody can use the database and start creating tables in that. All right. Because right now I do not want to get into that phase where I want to add uh, users into my SQL. Okay. But what you can do is you can add more tables into the same database called ScoopX. All right. Now we are done with creating the tables, and I mean our table looks good. Okay. Now we want to move this table into into the use into the HDFS. All right. So you ask Scoop to first copy it to the HDFS. All right. So you exit from MySQL and then say local call, and here because it is going to be ScoopX. Okay, scoop example, and tables, let me call tables as widgets, fine, and that's it. Now it should ideally give an error saying the database table already exists over there. Right. Okay, there is insufficient memory for the Java runtime to continue. The native memory allocation has failed, and these many bytes for oh, okay, so I need to probably kill one service on this device. Okay, and to kill this, I don't know what is taking so much of memory. Hadoop 1 and then say 8080. So probably maybe what will be the quickest way to do stuff here? Here on the, it shows all the nodes I have, and then I have hosts. And what is the situation of my second host? Okay, so maybe I'll just stop Gangalia for some time. Okay, and let it be running. Let Uzi, I'll just stop for some time. Okay, alright, and then I have Gangalia monitor, and I'll just restart this, stop this, and then this data node, because we are going to need data node, so I'll just restart the data node. Alright, and I will also restart restart my MapReduce probably. Okay, okay. So Gangalia is stopped, and clients, there are all sorts of clients installed on this machine, and probably I will just restart once I am through with this. Okay, now it should actually should give some results now. At least it should give an error saying this already exists, that folder already exists. So whatever is required only I have kept here. Now here says that yeah, so widget already exists. Alright, so there is this file already because I had been experimenting with it. Hadoop file system minus ls, and this is where our file exists. So what we are trying to do is we are trying to move a table into a file into HDFS. Okay, so there is already a directory which is existing, so we'll just delete this directory saying Hadoop file system minus rm minus r and widgets. So we are deleting this directory where the output is going to go, and now in the next stage we again try to run our scoop. Alright, so as you can see that this process also is doing some map reduces. Alright, okay. So basically what it is going to do is uh, it will distribute this import task onto all mappers, and each mapper is going to read this data and then import only that section into the file. Okay, I mean exact syntax I am not really very aware of it. Okay, it is going to take a bit of time, and probably even if it's over, right, it keeps on running, it doesn't end. Okay, so just to have a clear picture whether this particular, so it by default creates the same table name as same name of a file with the same as the table name. Okay, okay, so oh, sorry, I've actually deleted the home folder of the user. Is that right? Did I actually delete the home folder of the user? Oops. Okay, so let's see what is there actually. Oh, I've actually deleted whatever I did here. Let me just import it again. Okay, okay. So this is my scoop, import, connect to the database, table is widgets, and I'm now importing. Okay, so it is doing. Ah, now when you see this error, that means one of the node has gone again bonkers. I was thinking that 1 GB RAM is sufficient for a data node. Okay, but probably I'll have to move to some 4 GB RAM nodes, and then here one of the things has crashed. The resource manager has stopped. Actually, the resource manager has stopped. So I'm restarting that resource manager, and probably we'll sort out these kind of problem, these memory issues by Monday. Okay, so now it's starting. The resource manager is starting. I'm just hoping that it's, yeah, it is started. So now it's connecting to resource manager. It's doing something. Now it has created the task for the import job and also gave us a URL to display things. So it is importing now. It doesn't have any reducer job, it only has mapper. So that it distributedly creates this file and uses multiple nodes to query your MySQL and import that data into the HDFS. I'm just hoping and I'm keeping my fingers crossed that it doesn't give any error this time. Let me see if you have any questions. So Sasank's question is, how can you go into Ambari is you can just log in with the student and the same password. Alright. Yeah. So Bhagwat remembers one of the incident which happened at my one of the groups we founded in college, and there I deleted the source code just before 2 days of the release. Okay. Yeah, it is now able to do it successfully. So Bhagwat, your problem must have been the same, where the yarn is getting killed again and again. Okay. And here you can see this. Now let us go to Hadoop ls user root and let's see what it has created. Has it created a directory called widgets? Yes, it has. And under that widgets, it must have created a file called part. Can you see that? And now we can do cat on that part and see what is. So our MySQL table, which was widgets, have been converted into a plain text file by the use of. So it is comma separated file kept in the HDFS. Okay. So this is like conversion of your structured data into a sort of semi-structured data. Now you can see this. It has widgets. So as we run scoop, it interestingly creates a Java file for you. Okay, whatever you're trying to do is it creates that Java file for the same job, which you can compile and run in the server use cases. Okay, if you see it created a complete object for the translation. So in case you have to keep on doing it again, or in case of production environment, you can use this class for the conversion. Okay, so that you don't have to run the whole translation again. Okay, so basically widgets.java is a mapping between your MySQL and HDFS. Okay, so you can use this for future ones. All right, and because in any case of imports, right, any ETL, first you develop everything at some other place and then execute it at some other location. Okay, so that is why it gives you this class which you can use it later by compiling it and running it. Okay, so we were able to successfully import it, and we checked the content also. Also there was this Java file was created over there. Okay, now we want to import the data into Hive. Okay, but before importing this data into Hive, you will have to first create the table. Okay, and then load the data there. All right, so how do you create the table? You can use this command. Okay, not this way. So yeah, so ideally it should be there in the Hive already, and it should give a nice error saying the table already exists. Oh, I think when I deleted my home folder, this table went away. All right. Okay, okay, right. Now let's check if it is the table has been created or not. So we are creating a table in using the schema of MySQL database into Hive. Remember, in Hive we have to create those table structures. Select star from widgets. So this is where we are in Hive right now. Okay, so let's say drop table widgets. This is the old table probably. Okay, and let me do it this again, not this way. I again gave a wrong one. Okay, so I will. So first you create a table in Hive, then you load the data into the table. So this is one way. There is another way also. Select star from widgets. No table found. Okay. So there is another way also called this way, where we specify in this fashion. Okay. So you say scoop import, my connection URL is this one. Okay, I'll just create another file. Here our is scoop ex. Okay, and I say import into Hive. So I'm importing into Hive this one. Okay, so scoop import, and then we say something. Now it says that there is already a directory existing there. Okay, now instead of doing that, basically what is it trying to do? Okay, okay, so what is it saying is that okay, okay, so when you want to import both the things together as in you want to put in HDFS as well as in the SQL, then you use this syntax, okay, in HBase as well as in the file system. Then you use this kind of command. Right now what we are trying to do is, first we create a table in HBase based on our table in MySQL, and then load the file which we have copied into that widgets. Okay. So I mean, it's generally the way we put the data into HBase is, first we create a file in HDFS and then they move the data into HBase. Okay. Okay. Now let us see if the file, if our, what command did I execute? Okay. Select star from widgets. Okay. So widgets exist, but it doesn't have the data. Now we'll say load the data from a file called widgets, and it has quickly loaded the data into the widgets. Now here is that place. Okay, so we have moved the data from, sorry, we were not moving it into HBase. I'm really sorry. We are moving the data basically from your external system to the HDFS and creating an external table inside Hive. Okay, so we can see describe widgets. Okay, so this is the table which is created. Basically Hive contains just the schema, so we create a schema uh, in Hive using our MySQL table, and just loaded the data into this Hive table using our HDFS. Okay, so we basically successfully moved our data from external to the Hive. Okay, now this is the way you can move the data back from MySQL, from Hive to MySQL. Okay, okay, so is everybody with me? Nice. Okay, did it do a whole dump of the data? I did not see what format it was imported. Yeah, so when I did say cat, right? When I say cat, it showed you a comma separated format. And when I say here like this one, if you see this one, basically it is saying that there is a comma separated format, right? Field should be terminated by comma. So what I'm saying here is, here I'm creating a Hive table based on my MySQL table. And you remember when we used to create Hive table, we used to say that the data will be separated by comma. All right, and here whenever in the previous one here, so whenever you are importing data to HDFS, it is by default comma separated. Okay, so in this step, the first thing you did was copied the data or imported the data from MySQL to file system, which is by default, you copied from MySQL to HDFS using scoop. Okay, this is by default comma separated. Once you have done that, you created a external table inside Hive. Okay, marking that whatever files we are going to get load onto this table will have comma as the separator. And once you are done with that, you go into Hive and say load my file into this table called widget, which we have created in the previous step. So this particular step is nothing but creating a Hive table based on the schema of your MySQL table. Okay. Or you could do both the things, like copying of the file into HDFS as well as creation of Hive table in a single step. Okay. In a single step. All three things in a single step. Alright. Let me have a look. So Hive is the front end to all the places. Okay. Hive is not a storage of any kind. Okay. So whenever you create a table in Hive, you always say where you want to store the data. Okay. Now here in this case, you created an external table, or you created a table in which you loaded the data from HDFS. So I'm not connecting to MySQL. I'm connecting to Hive here. Okay. Um, should I go again over this, Bhagwat? Are you clear now? Okay. Let me explain again. Okay. Let me explain again. So here at this point, what I did was I created a data in my MySQL. Alright. Now second step is copy that data using scoop onto the HDFS. This is what this guy did. Okay. This is what this guy did. Alright. So it copied your SQL table from MySQL to HDFS file, where comma is the field separator and new line is the record separator. Now the next step is, so now your data got into the HDFS file. Now what do you do? Let's say in standard case, if you have to have some data into Hive, what you do is first create a table in Hive, then load that data, load HDFS data into Hive. Alright. And Hive is not a storage, it is just Hive also has a storage, unless I mean it stores on HDFS itself. Okay. Now, but to create a table, either you try to create a schema by yourself for the whole Hive table. Hive table, in Hive, remember, metadata has to be created. A schema has to be created, but the data is not stored on Hive generally. Alright? Because Hive works as the intermediary between NoSQL and RDBMS databases. That is why Hive maintains the metadata or symbolic table, external table or internal table. Alright. Now either you create by hand the exact SQL table what was there in MySQL, or you can copy the schema using this command. Scoop create Hive table, connect to the JDBC, that particular one, and using this table, and my fields are terminated by comma. And these fields terminated by comma, you remember when we used to define a table, and we used to say that when we are loading the data, it is going to be comma separated, and hence upfront while defining a table in Hive, we say that fields will be separated by comma. Alright. So once that is done, then we load the data from the HDFS into Hive. Now is it clear now? Now the data is another file in HDFS. Okay. Table widget is in HDFS data, and the schema is coming from MySQL. Yes. Great. Great. So everybody got this one. Anybody has any doubts? All right. Let's move on to the next case. So Bhagwat, any other question? No, right? Good. Good. So now let's move on. Great, 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 great. Thank you. I have a smiley. Okay. All right. Now we move on. Now the second stage is we want to take out data from Hive to MySQL. Okay. And this is called export. All right. So the first one was called import when the data was coming from MySQL to the Hive. So first of all, you create a file called sales. Okay. Let's just create a file locally called sales. So how many of you are aware of this kind of format? Okay. You could do couple of things. You could take this content and say nano sales. Nano is an editor on Unix, and this is how you could save it. Now if you say cat sales, it has the content you need. Alright. Now the second stage is you go into Hive and you create a Hive table and load this file. Alright. I have again I'm moving this sales into, actually I think I will move it to my folder. Which folder am I in, by the way? Oh, okay. So I will just delete sales.log. Yes. And I say nano sales.log, and in this I type, for those people who are not very uh, comfortable with VI, Nano or Pico are good editors. Okay, because VI has a little bit of learning curve. So till you learn VI, you can live with Pico or Nano. Okay, I've installed both of these things onto the server. All right, now we have got this. Sorry, I need to go into Hive, and let me also have a look at. So in Hive we are going to create this table, and what is happening, I think some format, or maybe this one. These people, what they think of themselves. Okay, they change the single quote every time I type normal single quote and it becomes something else, and that's where the most of the problems occur. Okay, sales table already exists, so we say drop table sales, and then and create again. Okay, done. Now you can see select star from sales. So we are creating a table called sales. In this table we will load from the local file where we created this. Okay, and yeah, so we'll see select star from sales. Now the data is well imported into Hive. Alright, the data is well imported into Hive, and we say yeah, so data is now in Hive. You can see that. Select star from sales. Good, good, we are all good, right? And here if you see, it's load data in path, and while here it's load data local in path. So without moving the sales.log which we created here, without moving this file into HDFS, we were able to load it into our file. Alright, while in the previous case the data was load data in path, which means it was in the HDFS. If you say local, it means the local file. Alright, and Okay, okay. So you guys are able to see my screen, right? Great. Now this is done. So we have got data in Hive, but we don't have the sales table in our database. And our database name is, if you go to MySQL and say select use scoop ex and say show tables, it doesn't have a, okay, it has only widget. Alright, so what you do is you run first, but before that you will have to create MySQL table. Okay, you will have to create MySQL table over here into MySQL. Okay, okay, use scoop x, and now the table is created. Okay, and now what you can do is you can say export, and here remember we have to use our own table. And whenever we create a Hive, remember this location. Okay, on the servers on Ubuntu, in HDFS, automatically a file is created onto the HDFS in this folder. Okay, whenever we create a table, we create a table which is into the Hive. Okay, so any Hive table which is internal creates a file into HDFS at the location app Hive warehouse sales. I'm telling you this because it took me really long while to figure this out. I'm just hoping that yarn client is not dead again. Okay. Okay, so let's see what is going on. It is doing something, and let's see if it is able to do some useful thing. Is it able to import the data from there to here? Okay, I think it must have done already. Okay, let me just check and say use scoopx and then say select star from sales. Okay, I think it is not done yet. Okay, FC2. Okay. Okay, it's taking quite some time, but trust me, it does work. Okay, so basically we will be able to successfully import the data like this using, why doesn't it It's taking some time. Okay, okay. Now what I do? I will have to keep our select star from sales. Now we have use. It's taking some time. Anyway, never mind. Let's move on. So every time it runs, it shows you. It show. Where is that one? Okay. Here, when it started the job, it was telling us to go and check. Go and check the URL to track. Okay, this is the one. Alright. So this is the one where it is actually logging everything. Okay, this is the place where it is doing the job. And it says that this particular thing is still unassigned. So probably again the something has someone or the another thing must have bulbed. Okay. Resource manager is working fine, history manager is working fine, and region manager is okay. And what about HDFS? Are all the data nodes running? Yeah, all the data nodes are running fine. Okay. Now we are here. Okay, and this job seems to be completely not available at all. It says it is unassigned. State is accepted, it is undefined. So this is what it is doing. Okay, so I mean it will either finish now or maybe after some time. Okay, let me just check one more time, and if it has done or not. Otherwise you can, yeah, it's not done, but it happens very well. So once or twice it should work fine after some time. Okay, and right. So that is pretty much about the import export from Hive. In the similar way, you can do import export from or to the various other kind of databases. All right. In the similar manner, you can do the imports from another databases. Okay. So I think that URL, I mean this one basically the URL. I'm not sure if that will be any useful to you guys. Okay, and here it is. So this is where it keeps on tracking. Every time a task runs, any MapReduce job runs on Hadoop, it gives you a tracker URL where you can track what's going on with it. Alright. For this task, it seems that it was never allocated any memory, or it was not allocated for the execution at all. Okay. So that was it. Or we can actually try once more. Scoop, export, connect, and then my JDBC is this, table is sales, export directory is fine, and yeah. So let's just put it in the background. Okay, it is doing something, and this time again, so here it creates a jar of sales.jar and uploads it onto the MapReduce cluster and let it do lots of things. Okay. What is going on? Okay. So somebody has tried to execute his script again, probably Bhagwat, and his job is also unassigned. Alright, okay. Nothing is running. These are accepted. Okay. It's too much of data. Okay. No, it's not actually correct working properly. This node probably again I'll have to do a recycle. Anyway. Now similar to, not similar to, but it's a little different than Flume. Than Scoop. So there is a product called Flume. Okay, this is this is also under the umbrella of Apache. This is specifically for the cases where you want to log, you want to transfer the logs from all the machines to the HDFS. So, so log has a property like all the machines will be creating the log and copying that log onto a central machine. Okay. So the role of job of the Flume is to take the data or fast flowing data from various machines in various kinds of formats to a central channel and then take it finally to the HDFS. Alright. So you have got hundreds of web servers, and what you want is to move these logs from the web servers to your HDFS continuously. Okay. So it's a very distributed, reliable and available system for the transportation of the logs. Okay. And this is specifically for the very large size of log and a long lot of machines creating the logs. And logs could be many format. It could be simply your Apache web server log format, log4j format, or it can be in the binary format such as Avro. Okay. And from different sources it takes to the central data store. And it supports various kinds of variety of sources, and sources includes things like tail. Do you remember when we have to observe a file in Unix, we say tail minus f. Okay, so in the similar fashion, the way tail keeps on reading the log file, similar fashion Flume will keep on reading the log file as and when the newer data is being pushed into the file and take this log file onto the central HDFS continuously. So basically Flume in a literal sense, it means basically a sort of a small channel, a small channel which carries the water from one place to another. So Flume is on the same lines. Okay. In Unix, there is something called syslog also. Syslog is also a central service in a case of a single machine. So Flume takes the logging to a different level altogether, having a centralized one. Okay. And the the general way of handling your logs is to have one node installed on each machine, or one agent installed on all of these server machines, and on every machine whenever we are setting up Flume, we tell that where to take this data to. Okay. the target and the source and all those kind of configuration we do for Flume. And that is why Flume nodes can be arranged in arbitrary topologies. Okay. And because everywhere each of the Flume node knows that what kind of format data it is going to receive and where it is going to send, and there could be mediators. Each node can also mediator for other ones, and that is one mechanism. By communicating between the nodes, it is able to send the data from arbitrary nodes to the central HDFS. even if Even if the data between the two nodes, one of the nodes which was in the communication gets down. So it's like your peer-to-peer system also. All right. So basically, it's a very reliable way of transmitting the log information. Okay. So there are multiple nodes, and there is every node has got source and a sink. Basically, what kind of data format are you each node of the Flume is accepting, and what kind of data it is going to where is it going to send it to. Okay. And there are two kinds of guarantees or delivery reliabilities which Flume gives. Is first one is best effort delivery. Best effort delivery is it doesn't tolerate any node failure. Okay. So okay. So in case there is a node failure, then it gives an error and it doesn't move ahead. Other is end to end, which means it guarantees the delivery. Okay. Even if there are multiple node failures between the source and the HDFS. Okay. By the way of communicating to other nodes and transmitting the data from there. Okay. Okay. Yes, Anto's question is right. So Scoop is a helpful tool to transfer the data between Hadoop and the relational databases. You are right. Okay. And right. So tail minus 100f alert.log. It's log switch type of stuff. Yes, it's on the same lines. And it's basically centralization of all the logs being generated by all your machines. Okay, so most of the services in these environment, wherever you handle the big data, they run in hundreds of numbers. The way in case of our retail website at Amazon, it used to run in hundreds of numbers. Hundreds of nodes used to run it. Okay, and basically all of those nodes were communicating to a central service that here is my log, here is my log, and they all keep on transmitting that to the central system. All right. So that is pretty much uh, with respect to Flume. I'm keeping it very short and sweet for each of these topics. Okay. In case you have to dig further, because knowing is sufficient. Like what does a particular component do, and in case you require it further, you can dig down and look at the manual available at the Apache Flume itself. Okay. It is generally for the Hadoop administrative task only. Okay. But this can also be used as event log. Okay. Say you built an application which generates a lot of matrices, with respect to your application execution. Finish this, finish that, finished processing these many records, and that kind of mechanism. And all of the machines are doing it parallelly. and so this log is going centrally, and now once it reaches HDFS, you can process this log for the other jobs. Okay. Okay. So basically, other than logs, it can also be used for matrix computation, where you are trying to analyze your flow. Okay. And so you keep on logging the various kinds of event in your application into the file system, and at a later point of time, you can use all of the logs to generate some sort of analytics. Okay. For the real case, can we use Flume to import log? Yes. And use scoop to import to Hive? Yes. And that, I mean, that's what these two tools are meant for. Okay. No, if Flume doesn't do that, Flume doesn't move the data directly to Hive. Okay. Flume's role is only limited to the logs. Okay. And Flume copies the data from various nodes to a centralized HDFS. Okay. Okay. Now, okay. So this is okay. Right. Now, next one is your after Flume. There is something called Uzi. Uzi is an important concept. Basically, whenever you are building an application, say for example, take a case of, say you are building a you are doing some sort of churning of Apache logs. Okay. Now, so first and foremost, what will you do is you will cleanse your Apache log, and after you have cleansed the Apache log, you will load this data into maybe Hive, or or you will load this data into Pig and do some sort of analysis, save the outcome of the Pig onto the file system, and once onto the file system as in onto the HDFS back. Once you are done with it, you will, once that finishes, once your Pig job finishes, you take those output and you start running your Mahoth job. Okay. And at the end of it, you will get some output. Now, this has to be changed together. This has to be changed together such that all of these things happen in that sequence. Okay. So for that, there is an idea called Uzi. Uzi is similar to what you have Ant. If you guys have used Ant or Makefile system, have you guys used Ant, Makefile, or any other, say, say for example, how should I say, Maven, for example? Okay. So, have you guys used Ant or Makefile so far? Okay. Okay. Right. So Jenkins is more like a tool where you configure things, but in case of Ant, you basically say which project depends on what, and each one does some things. It is similar to the make tool, and MVN also is the same. Okay. Okay, great. Now, what you do is that in case of Ant or any of these, you define something called action. Action can be something very simple as copy this file from here to there after substituting these two variables. Okay. And then there could be an action called compile this particular file and put it in this folder. Okay. Now, when you are building a project, what you do is you chain these all tasks together in the form of a graph. A depends on B, B depends on C, comma D, and D depends on further so on. Okay. Now, in this way, you have got, say, A depends on B, okay, B depends on C, comma D, and C depends on, say, D, and D depends on, say, E. Now, if you draw this diagram, okay, if you draw this diagram, it will become something of this sort, okay. And I mean, how can I basically draw this diagram very well? Okay, okay. So we have got, okay. Now, how can I show it very well? No, I can't do it. I'm not that great with this. So I'm trying to show that C is pointing to here. This arrow means C is pointing to D. Okay, and D is then pointing to E, right? When you do the execution of so you have got a task called E. E is basically preparing the variables, basic variables, in case of, say, ant task or any other make file or any other uh, way you have used. And then you have C comma D. C depends on D and B also depends on D. So D will be executed now, and then C and then B, and so on will be executed based on this sort of dependency chart. So such kind of graphs are called DAG, directed acyclic graph. Basically a graph where there are no cycles at all right. In the if, and these directed acyclic graphs are very frequently used in these circumstances, such as a dependency list in case of a project management. In project management, you also break down the whole task into various dependencies, and each dependency has got further dependencies, and there are edges, in the sense that like the way we have an edge here, meaning B depends on C and D, so we will be ideally making something of this sort, okay. And say we say here we have got D, and there is a line is coming from which is coming from C, okay, onto the D, and then E, okay. So you can visualize it in this fashion, okay. Okay, finally I am able to make something sensible out of this, okay. So basically what I'm trying to demonstrate over here is uh, this. Okay, so A depends on B, B depends on C, and B depends on D also. Okay, B depends on C and B depends on D also, and C depends on D, and D depends on E, and C depends on E also. So here, if you look at this graph, okay, if you look at this graph, it is basically a little complicated graph, okay. And but the important criteria is there is no cycles in it. A to B, B to C, B to D, and C to D. There is no edge back from D to B, all right, and from D to E. So if you in any project planning or in any kind of ordering of the task, having such kind of a graph is very common, okay. And in the similar fashion, whenever you are working with Hadoop, say you are doing a project, in any kind of a batch processing, you require this kind of dependencies. Alright? And same is the case with your Maven project, Ant, or any other make systems and Visual Studio build order, as Kumar says. And so Uzi is nothing but providing the same functionality in case of your Hadoop jobs. Okay. And there is one more thing called coordinator jobs, which is nothing but a scheduler. So either you will trigger a job, or by yourself, by manually clicking execute, or Uzi will do it periodically for every day at certain frequency or at a later point of time. Okay, so based on the schedule. Okay, so that is the role of Uzi. Before Uzi, the same functionality was provided by Azkaban. I was using Azkaban in case of my project, in earlier projects. Okay, but Uzi seems to be far more stable and uh, very well supported. Okay, Uzi is written in Java, and hence all the projects which are already there for doing these kind of jobs can be quickly configured into Uzi. And it is very well integrated into Hadoop stack, and very reliable and extensible system, in the sense that each of the work can be extended. If there is an action which does not exist for your kind of job, you can extend Uzi and create your own. Okay, so this looks really small for you guys. Okay, let me have a look. How does it look for you? Can you see this? So here I will actually, a better thing will be I take up a action. Okay, so here let's say there is a, and similar to this is exactly like a your aunt task. Okay, I will just go through this very quickly. You so first of all, while you defining your XML workflow for Uzi, you first define workflow app and its name, and then XML namespace. Okay, this is just you can just simply copy paste and change this name. Now, and then you define, like a XML nodes, various actions. Every action has got to have one name, okay, by which this is identified. Okay, and here you define start is one point which the Uzi will try to find out to seek the entry point. Okay, now now here if you see, uh, we have got action called word count. Under this, we first do some map reduce job here. This is our map reduce job, which we have configured in XML, saying our mapper is this, reducer is this, map input directory is this, output directory is this. So this is our map reduce. So this is a standard task or standard action under the workflow, under the Uzi, okay, which is provided by Uzi. And here you say that in case it is okay, everything runs well, go to end, which is this one. In case there is an error, then also you go to the end. Okay, and you can also define furthermore, in case some it was killed. Okay, it was killed, then this is what message is displayed, that something went wrong and we were killed. Okay, so this is the general format of any Uzi workflow. Every Uzi workflow is either defined in terms of XML, or can be created by the Java library, instead of defining this whole graph. And this is the general way of each action. This is how each action looks like. Each action has got a starting point, and one is okay and other is error. Okay, but most of this is now automated. You don't have to type all of this XML. Okay, again, this is how a directed acyclic graph looks like. So fifth task depends on 11th, 11th depends on 2, and 11 depends on 10. But you see, there is no cyclic graph in it. So these are directed, but there is no cyclic. All right. So if you start traversing from 5, you will reach to a point which are edges. Okay, so like 2 is an edge, 10 is an edge, and if you keep on going, then 9 is an edge for if you start with 5. And all of these can be executed parallelly and without any worry. Alright? So all of this execution is very well taken care by Uzi, and these are the actions provided to you by Uzi by default. First is MapReduce, as we saw. So these nodes which you see like 5, 2, this one 5 could be a node called your starting point. 11 could be your MapReduce, and ninth could be something else. And out of this whole list is basically those actions. Okay, and streaming job is that Python job or any other binary we should demonstrate it in the second class. And then executing any Java program, you can use a action called Java. All you have to do is say in the like we have said fork here, you have to do that way. Similarly, you can execute a pig script straight away, hive script straight away, scoop also you can execute from here, and then cell also you can execute, and so on. Okay, and most importantly, yes, Uzi also provide you a scheduler like cron job in Unix. Okay, so so basically you define this XML and then call the Uzi command line and hand it over this XML. That's all. And also you have this you have hue which works well with respect to right now the hue on our the data center is not working. I'll fix it by this Tuesday, and will let you know. Okay, I have got data center guys now who can help me in fixing these issues, because I'm not really great with the admin of Hadoop. Okay, so I have got few people who can help me with respect to setting up the Hadoop. And now this week, by the end of this week, we'll have everything running really well on our data centers. Okay, so that because the project time is approaching, now all of you will require multiple nodes to do your project. Alright. So right now I'm trying to show you how can you use to Uzi for your tasks. Okay. Okay. Here, this is my okay. Now you have here a dashboard of Uzi, It's a nice dashboard. And this coordinator is it is showing you what are the workflows running right now. None is running, and coordinators are that schedule job which run in the background, and there are no coordinators running right now. So if you have to create workflows, you have to go to the tab here and then create one sort of job. All right, and say I'm creating my workflow called test 1 and test 2. Okay, and there, once you come to this screen when you are creating a workflow, you see this nice UI where you can pick up a task and drag and drop over here. Okay, and then you define, I'm dropping my MapReduce task, so I can browse to my jar and then put it here. As well, uh, I can have streaming jobs, Java program, any of these in the sequence for execution of your task in that order. And okay, so this one is your standard Java MapReduce jar. This one is your streaming jobs. Objective of a streaming job is you should be able to do MapReduce using any programming language. Then you have got Java command. So if you have got some Java program which is not MapReduce, you can use that one over here using this particular action. Okay, there is a starting point, this is an ending point, and you can have your pig script like this. You give it a name, then give the browse to your HDFS or any I mean to the HDFS and select a particular pig script. Okay, over here, and then it will get executed. So similarly, you pig is there, hive is there, you can execute hive, then scoop whatever we just discussed, you can say take a scoop and put it here, and then you have these commands, import, export, all of those things which you saw on the command line, you can put those things. Okay, all right. Now, other than that, you have shell command. Those people who are good at awk, sed, and everything, they can also write their program in the shell and put it here. Okay, so you can select your cell program to execute, and then that will be good enough. Similarly, you can have SSH, which means remote shell. You can execute a command on the remote. Okay, if you want to say do some other operation on some remote server, you can do here. Okay, and then there's something called distributed copy. Okay, distributed copy is really good phenomena. If you have to copy huge file back and forth, or huge folder, or huge archive back and forth from local file system, you have to copy the from the local file system to Hadoop or HDFS, then this CP is really efficient. Okay, it does a lot of optimizations by itself. And then any HDFS command you want to execute, like create a path, create a directory, move a file, touch a file, and all those kind of things. Whatever Hadoop FS, whatever command you can do there, you can do here also. Alright, and if you want to send an email in the middle of workflow, you can use this particular action, and you can execute another of your workflow in middle of it. Or if you want to have completely generic in the form of your own XML, then you can write your XML here. If you want to define your own XML, you can also define here. Okay, like it is saying that. Okay, if you're not comfortable with the dragging dropping, you can also click on generic and type your whole action over there. Okay, so this comes as really useful. And you can also import your
XML file to become the to have the uh, to be appear on the workflow editor. All right, and once you are done with creating your flow, you can say either submit it or schedule it, and that's it. Okay. So general idea is when you are building things, so you'll start manually copying file from remote to HDFS, then you will do some more churning. You keep on noting down all these steps. Okay, and once you are done with it and everything is running fine, you create a OG script or create a OG XML file out of these all steps and let it run either periodically or run it once, or whenever you want to run it you can run it from here. Okay, so that's more about what it is. So Anto is asking, can you create a simple workflow and run for us? I'm not sure if this Hortonworks box supports it. Let me try running it because my machine can crash any moment of time right now, because it is running first Google Hangout, then having the recording in the background. So okay, so in case it crashes, okay, I think you guys should actually try it out. It is not a big deal, but right now very afraid of running anything inside this virtual machine. Okay, I'm being a little risk averse over here. So, and also you should have a look at various workflows which come by default in Hortonworks machine. Okay, if you click on workflows, okay, so let's take a case of email workflow. It simply sends an email to people here like this, or let's take an example of, okay, okay. So this is one MapReduce job which sleeps for some time. Okay, and you can run it. You can actually just select it from here, select something from here, and then say submit, and then see the magic. Okay, and I will not take a risk right now. All right, but you guys should give it a try. Okay, and let me know if it is working or not. Okay, yeah, you guys should give it a try. It's not that big a deal, and let me know if it works or not. Okay, consider it as your assignment by running at least building at least one job which has one pig script and one streaming job. Okay, or Hive combined with pig and a streaming job. You should run that onto your local machine, and by after Tuesday you can actually run on the server as well. Okay, okay, now let me have a look now. This is fine. So you can go over the more documents over Uzi over there. Use case to you should be very clear about your use case of each of these components. So Flume you use in case of importing the logs. Scoop you use in case of importing data back and forth to and from structured data store. And Uji you use for execution of multiple jobs in a certain manner, in a certain sequential manner. Okay. and either by you, it can be either triggered by you or can be triggered by the system itself. Okay, like here we can say that schedule this particular action schedule this particular action at a certain period of time. Okay, okay, my job, okay, whatever some job, this is basically Hive simple workflow, and right, and then is shared or not, and then you can define a particular frequency here, and I think it takes it basically internally it creates a cron expression. Okay, also also you can define whenever in any of the variables values whatever you're putting, you can define variables inside the angle brackets. Those variables will be given, you can fill in those variables by while execution. Okay, so let's just go ahead and say I don't know what time I have executed it, and okay, edit properties, my workflow coordinators. So this is the one which will get executed at just now. Some other time. Okay, so this way you can actually schedule your job. I'm pausing it. I'm pausing the job. Okay, right now I've just paused the job. I mean, moved it to trash so that it doesn't get executed. So you can read more about Uzi over there. All right, and that's pretty much about Uzi. So any doubts still here? So are you clear about what are the roles of Uzi, Flume, Scoop, and all of these? Great, great, great. Now the next one is I'm going to just scratch the surface of Mahout. Okay, and then uh, in the next session I'm going to I'm going to basically give a basically hands-on demo of how to use Mahout, a very simple recommender. Okay, and but before that I would like to take a break, and okay, so we come back after 10 minutes. Is that all right? Let's come back after 10 minutes. Okay. Okay. Hi guys, I'm back. Hello, hello. Okay, okay, okay. Is it audible to you? I don't see. Okay, okay. Now let me share my desktop. Okay. So now we're going to talk about something called Mahat. So Mahat is basically a machine learning library which is built on top of Hadoop, but now it is no longer dependent only on Hadoop. Okay, it has been also ported to other platform and it can also independently run. Okay, so it is basically driven by NG and ETL's paper called MapReduce for machine learning on multicore. There was a paper published by one person called NG and other persons, and it was started as a sub project for a project called Lucene, and then in April 2010 it was adopted by Apache. And Mahat in Hindi means a keeper or the driver of elephant, the guy who sits at the elephant. You see this blue guy who's sitting at the elephant? He is Mahat. Okay, so he drives the elephant. Now, machine learning is a basically what before we start talking about Mahat, we should know what does it mean by machine learning. Okay, and machine learning is basically performing basically instead of you writing the code, you are letting the computer figure out a correlation between input and output. Okay, and this correlation can be used in optimizing a performance. Okay, using some example data or some past experience. Okay, and I will come to more examples very soon. It's a, it's basically a branch of artificial intelligence. The machine learning is basically a branch of artificial intelligence designed and developed. Basically, machine learning is a branch of artificial intelligence which involves the design and development of algorithms, and where the computers evolve their behavior based on the data. Okay, based on the data. In most simple format, you can think of if you have 3 points, 3 points uh, on a graph, and you draw a line on these 3 points, or you try to draw a graph on these 3 points, or say 10 points, your ability to predict the graph based on say 10 points is also considered automatic learning. Okay, you build a system which automatically predicts where will the 10th point be based on where will the 11th point be based on given 10 points. Okay, so that is a form of learning. Okay, so and machine learning is very prevalent, and machine learning is no longer a, a magic. Okay, machine learning is used extensively in a lot of things, and there are two forms of machine learning. One is simply statistical way, and other form of learning is in the form of neural network. Okay, Now, there are three types of machine learning. First is supervised learning. Okay, supervised learning as in you guide, you tell that this is right, this is wrong, this is right, this is wrong. So we have got a training data where each of the input point where we have labeled it. We have labeled it as right or wrong or some other format. Okay. Say this data belongs to good, this data belongs to average, this data belongs to bad. Okay. So we can label this input data and feed it to the computer and let computer after some time when after say millions of records the I, machine learning helps in taking rest of the calls. You did not have to analyze this data by yourself. Machine did it for you. Okay, it automatically plotted the graph internally. It automatically learned by using neural network or other mechanisms. So that is supervised learning. And unsupervised learning, using unlabeled training data to create a function that can predict the output. Okay. So unsupervised learning, how should I describe unsupervised learning? Basically, our training data is uh, so when we say that we got 10 points on a graph, okay, now the job of this guy is to predict the 11th point. That is unsupervised learning. And if we had so many points and we had labeled each of the points saying this point belongs to this kind of label, this point belongs to this label, and given the next point, his job is to say what what does this new point belongs to. Okay. So that is supervised learning. And unsupervised learning, you do not tag or label the input point. Instead, you expect this program to give you the recommendation of the next set of things. Okay, based on the old ones. It's you want computer to do the extrapolation for you. Okay. And there is semi-supervised learning, which is somewhere between supervised learning and unsupervised learning. Okay. So you have got a lot of label data and you have got, very small cues which you also try to figure it out. Okay. So there is a very not enough labeling is available. Only some amount of labeling is available. Sort of hints are available. Then we call it semi-supervised learning. Okay, but in most of the cases you say that semi-supervised learning and supervised learning are the same thing. Okay, so these are the types of machine learning. Okay, there are zillions of applications of machine learning. The only limitation, I will come back to limitations. Let me just say, so the way you have, you have Facebook and you have LinkedIn, they recommend friends to you. Okay, right now they only count, some of them only count number of common friends you have with other people, but it can very well be built. It can be very well built such that it should start recommending friends based on your existing set of friends. Okay, automatically, and recommend friends, recommend dates, and products to end users. Recommend dates as in the way you if you guys are using Google now, it automatically recommends you the time to go to office, time to go to home. Okay, and similarly, if you have seen Amazon's way of giving you recommendation, where since you liked it, you may also like these. Okay, some of those are machine learning, but most of them are sort of statistical analysis. Okay, Now, you can classify content into predefined groups. The biggest example is your Google inbox, where it automatically categorizes emails into various labels. Okay, so that is classifying content into predefined labels or groups. Right now, it automatically, uh, you know, uh, moves some of your emails into updates, some of the email into social, some of the emails into normal primary, and so on. So, and some of the emails automatically go into spam. And there, it extensively uses machine learning to figure it out. Okay. Find similar content based on object properties. Identify key topics in a large collection of text. So these are very important applications, and there are a lot of libraries also built for these exact kind of objectives. Say you are given a corpus of text, a huge corpus of text, or say you are given a paragraph, simple one simple paragraph, and you have to quickly tell what are the five most important topics does this article belong to. Okay, for doing that, it is little difficult to do. Okay, and best way to do it is using machine learning techniques. Similar is your ranking search results with user feedback learning, classifying DNA sequences, sentiment analysis or opinion mining. Okay, and doing a lot of computer vision. This is computer vision is a very big use case for the machine learning applications. Like for example, in case of image these days, all of these applications have something called face recognition. Okay, as well as recognition such as which photos contain smiles. So all of that comes under the computer vision, computer's ability to see things. Okay, and that is heavily aided by the machine learning. So you, the way recently somebody was doing that, take a lot of photographs, okay, lot of photographs of dog, and give it to the machine learning algorithm. These are the photos of dogs, these are the photos of cats, these are the photos of this animal, and this machine learning algorithm was learning all of this, so that if it sees a cat, it will be able to identify it as a cat. Okay, so that is computer vision. Now, natural language processing. Okay, language processing is a very big deal, because right now none of the language processors are really great. Okay, because say there is a website which contains lot of reviews about the product. If you can, by reading the language, if you can figure it out if this review is positive, negative, or if it is positive, then how much positive it is, then you have solved the natural language processing problem. So most of the time natural language processing is heavily aided using the machine learning. Okay, by identifying the patterns. Bioinformatics, speech and handwriting recognition. This is one area that also requires a lot of training data, and hence and then do the machine learning on top of it. Okay, so here these are the tools. Okay, these are the tools available as of today based on the data size and the kind of classification or objective you are having. Okay, first one is like very small data. You have got a small data, so there is a tool called whiteboard, or you can you can draw on the whiteboard, okay, by yourself, and be happy about the visualization and analysis. Okay, and if the data is in few kbs, then you can't do it just by using a whiteboard. You will have to use something like MATLAB, a few MBs, say 10 MB, 20 MB sort of data. If you have that sort of data, all of these processing, Octave, R, MATLAB, they will be pretty useful to you. Now, if the data grows little bigger, then you will need to have NumPy, SciPy, and all of these kind of new libraries to do the analysis, and and, and these ones for doing the visualization. Now, this is where Mahout brings the value. If you have gigabytes to terabytes to petabytes of data, then to analyze that you require uh, tools like Mahout or Giraffe. Giraffe is basically a simple graph algorithm, and something Hama. But Mahout is the most complete machine learning tool out of all. Okay. Now, okay. So, any questions still here? You do not visualize with Mahout, in as simple as that. Okay. So, you do not visualize with Mahout. Mahout is just for analysis. Okay. Now, this is, I mean, one of the algorithms. You can think of this will give you a very great feeling. Say you have got recommendations of you have got the past history of users. One user is Sandeep, other is Kumar. Now Sandeep says that Matrix movie I'm giving 9 rating. Casablanca I'm giving 9. While Kumar says that I'm giving Matrix 9 and Shawshank Redemption 8.5. Now, this is just four data points, okay? This is just four data points. Now, imagine there were hundreds of such, or say millions of such reviews of millions of people. Sandeep must have given rating for hundreds of movies. Kumar must have given for hundreds of movies, and so on for millions of users. So 100 million such ratings. Okay. Now, based on that, you have to figure out which movie to recommend to who. Which movie can you recommend to who? You can use Mahout. And there is something called Tanimoto coefficient, which is very simple way where it tries to find out the commonality between A user and B user based on it tries to find out the similarity index, meaning total number of similar movies these people like divided by total movies they have watched, total distinct movies. So that is similarity index. So Tanimoto coefficient will basically uh, do this kind of analysis, and based on similarity index between two people, it will start grouping them together, and it will start giving recommendation of one person's movie to another. Like here, Sandeep and Kumar are quite similar, 50% similar. Out of three movies, they like one movie, which means 30% similar. And hence, it is okay to give them recommendation. So, Kumar likes Shawshank Redemption. So, and Sandeep like Casablanca. So, it is giving a cross recommendation. So, the movies Sandeep liked has been given as recommendation to Kumar, okay, while a movie which has been recommended to Sandeep is something liked by Kumar, right? And there are high chances they are going to like it, okay. So this is just one algorithm called Tanimoto coefficient way, where we have just what it has done is it has found two users similar to each other and started, or multiple users similar to each other, and then see what is the most common movie which these people like more, and then give that particular recommendation to the people who do not have watched that kind of movie in that particular group. Okay, so it will group the users together and say these users are similar. Now we can give recommendation to of one to another one. So it is like 10 people out of 100 of people, it has figured out that these people have similar taste in case of movie, and hence giving a recommendation from one to another is good. And that too, if say more than one person is liking a movie, then it can be given as a higher rating or higher chances. Okay, that's the last column. So this kind of algorithms is what makes Mahout powerful. I used this algorithm for building my recommendation engine, and that was giving really marvelous results. Okay, that was giving really marvelous results. How do you visualize? Okay, it's basically a type of tool as well as analyzer. Okay, it's basically a library which has multiple uh, components, and in this case Mahout takes three column values and input and gives out three columns value in output, and both of these things are kept on the HDFS. Okay, so you execute Mahout and tell it that, hey, this is where my input data is lying. Can you give recommendation based on that one? And Mahout will do the job and put the data back onto HDFS in the form of recommendations. Okay, so I did not get your question, Shashank. This is an analyzer or one type of tool. So this is basically you can say a tool which is an analyzer. Okay. And Anto's question is this sentiment analysis? No, this is not sentiment analysis. Sentiment analysis is a little different thing. Sentiment analysis is done when you are launching your product. Say you are launching your new campaign or new product into the market, and you want to see what is the common sentiment about my product. Okay, so what you do is, on before launching your product, you crawl the whole Twitter and try to understand that what are the negative keywords used against your brand name, or what is the negative keywords being used with your along with your any of your products, or the product you are planning to launch. How many people are saying bad things about it? Okay, now you figured this out, that this is what is the social sentiment about my product. Now you launch the product, again did the same sentiment analysis in the form of, basically, you crawl the whole tweets, the whole Twitter you crawled, or you asked Twitter for the whole data. Then, with respect to each tweet, you marked it negative or positive based on the keywords in the tweet and the order in which they have come in. So you have a huge dictionary which says that a particular keyword is negative, positive, or irrelevant. Okay, and you use that dictionary in conjunction with your Twitter data. Okay, and you count such kind of, like, how many tweets are positive, how many negative, and how is your positive and negative overall sentiment going with time or with hour. Okay, that is called sentiment analysis. Yes, in such situation you generally get the whole Twitter database and then try to figure out basically what people are telling you. Okay. Alright, so that is what is the sentiment analysis. Was I able to explain, Andrew? Bhagwat, you got your answer? Yeah, great, great. So this one is a recommender example where you are given three columns, it gives out the three columns, some other three columns. All right. So this is the one which I had used in past, and I was very happy because I did not have to do much of the magic. Okay. Yeah. So Bhagwat's question is, do we pick Tanimoto algorithm or on our own, or was it picked by Mahat? No, you will have to pick it by yourself. Okay, there are Pearson correlation. There are at least 10-50 kind of algorithms just for recommendation, and every day a new algorithm is coming in. So you will have to understand what exactly are you looking for. Okay, and then pick the one, pick the algorithm which suits you more, uh, rather than the other one. Exactly, you got it right. So it has got a lot of algorithms. Whatever you want to use, each algorithms will have certain input data requirement and certain output data requirement, and and we use it like a MATLAB. Yeah, and in case you can write your own, then you don't need Mahat for your job. But because Mahat is not any kind of a utility, Mahat is not any kind of a utility which exposes anything other than providing you the machine learning. Okay, so you can write, if you are able to write your own, you write your own, either in terms of MapReduce or any other phenomena. Okay. So few of the use cases other than the examples, who adds more ML algo to Mahat? I mean, who are you expecting to? There are lot of scientists who keep on doing it. I think you should do this analysis. That will be an interesting one. I would like to look at it actually. I haven't gone through that. Okay. But in case of Amazon, we had a great team. Basically, all we did was at Amazon for there was a separate team. We used to call it AML, Amazon Machine Learning Platform. Okay. All we did was we took Mahat and just renamed it and said, Ki, this is my our Amazon machine learning from today. And there were a lot of contributors inside Amazon itself. So in that team, other than me, most of the people were Israelis who were contributing a lot to the algorithms. Okay. So that's an interesting thing to notice. You should actually go through that contributors list. Okay. All right. Why does it keep doing? So in case of Mahod, there are some, I mean, earlier we talked about a lot of examples. Here are some of those in little more technical terms. Collaborative filtering. Collaborative filtering is basically, in very plain English, it's a recommendation. Okay, collaborative filtering can be based on based on user to user. This person liked it, so you also will like it. And product to product, people who liked this product will also like this. Geography to geography,
people in this product is popular in your geography, and hence you may like it. All of these sort of recommendations lie under a term called collaborative filtering. There is a very nice book on collaborative filtering. Those who want to study that, you can just search for collaborative filtering. The first book that comes in will be is really good. I will tell you, collaborative filtering. Okay, and no, not here. It is nice book, not this one. Okay, so basically collaborative filtering is nothing but various kinds of recommendations, and Amazon recommendations or Netflix recommendation are probably the most popular ones. Then another use case is clustering. Clustering is basically clustering users together based on certain properties of users or products or anything else. Okay, just like Google has clustered the emails together under various labels. Okay, and looking at the web pages, if you can quickly say, you have to find out of the whole world wide web out of the whole world wide web that you want to find out quickly the companies which belong to big data solutions. All right, so or which belong to enterprises and which belong to consumers. So such kind of clustering can be done looking at the even the text which comes into these companies website. Okay, and that can be done very well using Mahat. If you train it by say with 1,000 company names and their website, then it should be able to do it fairly good job. But 1,000 will be smaller. You should do it with at least 10,000 to have a better results. Okay. Then classification. Okay, classification, I mean, is labeling. I gave a wrong example in the Gmail case. The Gmail case is the classification. Clustering is more like product, cluster products together which are similar to each other. Okay, classification is broad category, broad buckets on which you put users. Okay, now fourth use case is frequent item mining. Okay, so frequent item set mining is items in shopping cart, for example, or terms in queries. Okay, so basically frequent item set mining is those people who buy these things frequently together. And I mean, the way when there was one problem, right, where we said when you type happy, you should give recommendations such as birthday or some other words, okay, based on a corpus of text. So that is frequent item set mining, a quick, frequent, uh, frequently used words together. Okay, so that's what is frequent item set mining, classification, clustering, and collaborative filtering. These are very important topics. If you guys like this topic, I can take it little more into deep. Okay, in the sense that we take one example of these use cases and try to run it. How many of you find it interesting, this kind of topic? Okay. Okay. Okay, so I will,
Hey Gaurav, my question was that do you find this useful? Do you find diving a little more deeper into Mahat? Because Mahat is generally, taught in case of data sciences classes, okay, and not in Hadoop. That is why I am asking. So Kalyan, what is your opinion? Suksavat and Kalyan, should we dive deeper into machine learning or Mahat, or should we move ahead? Okay, okay. Suksavat, are you listening? Probably Suksavat has gone to sleep. Oh no, he's awake. Suksavat, so my question was that I want to take a little more time on machine learning. Okay. And basically, I want to give one example, maybe a sample Java code showing you the use case of all of these things. Okay, and my plan is to at least give three examples, three different running examples of Mahat in three different problems. ठीक है? Okay, so I will take up Mahat in the next session. Okay, I'll take up Mahat in the next session, and and basically these topics are more towards the data sciences, and and the important part is that anywhere you read about big data, the use cases of big data and the whole big data jargon is all about basically machine learning. Okay, the first book that was published on big data actually made it made machine learning popular. Okay, so after a point of time, machine learning and big data became synonymous for a lot of people. Okay, so every time you see an intelligent, smartest thing done by machine learning, people say, "Oh, this is a big data solution." Okay. So that is why it is important to take at least few examples and go over when to use which algorithms and how do you use those algorithms. Okay, which means it might require a bit of programming, so but it won't be too much of programming. Okay, so I will take up Mahat in the next session, and today's session is is up to only this point. So if you have any questions right now. And as an assignment, try to import data from various databases, whatever database you have, or try to import from MySQL, create a table, try to import from that to Hive, and then and back. So that is the first assignment you should do. Okay. And second assignment you should do is run or build a Uzi job for you remember our first problem, voting problem. Create two map reduces to solve that problem, and do create an Uzi job to solve that problem. Okay, these are the two assignment for the next class. Okay, so first assignment. Okay, I will just put it here. Okay, so assignment, the first one is that create I mean import data from MySQL to Hive and back. Okay, Try doing it by yourself. You will get a lot of clarity. Even if you are just copy pasting the commands, still it will be a very good exercise. Okay. Build an Uzi. Build an Uzi job. Uzi job for the first assignment. Fourth, the fourth problem of session 2 assignment. The voting voting problem. Okay. If you remember, we had splitted that one into, okay, assignment, and that is the voting problem. All right. Okay. And also go through the big data sets big data sets available at Amazon EC2 big data sets. Okay. If you go to Amazon EC2 big data set. Okay. These are called public data sets on AWS. Okay. Okay. So go through these databases, and and there you will see lots of different kind of data is available. Okay, in various domains. Okay, and then if you come up with any idea that, hey, this is the churning, or this is the kind of interesting analysis you want to do. Okay, after looking at the data, after looking at, say, world population or geographical data or any kind of data, if you wish to do certain kind of operation, then I would like to do it. I would like to assist you in that. Okay. I actually, their version number, right? Hortonworks 1.0, 1.2 does not have yarn in it. Okay. From the usability perspective, there would not be much of a difference, but maybe one or two utilities might be missing. Okay. Okay. So I think maybe there is a problem with 64-bit or 32-bit. For me, it was actually pretty smooth. So are you using VMware or VirtualBox, Anto? VirtualBox, okay. VirtualBox, and you are on the Windows 8, right? 64-bit. No, you downloaded 64-bit. The Windows you are using, is it 64-bit or 32-bit? That machine. Okay, okay, okay. And that's a very strange error you get. Okay. So just check in case of 1.2 if you have the things like things like scoop. Okay. So if you have scoop, Uzi, and all those things available, then it's good to go. I think it would be there. Okay. I think it would be there anyway. The only problem is that one might be having the older Hadoop. Okay. Okay, Hadoop 2.0 is probably available in the second version. Okay, so these are the things available in case of. All right, I do not see. So just look at it. If almost all the tools are available, and with respect to our problems are okay. We are okay with any machine because our map reduce or any such thing will work everywhere. Okay. So what I was telling you that go through these big data sets, okay, and if you find certain problem really interesting and you want help, say you came up with an idea of doing something with the big data which is available over there on this URL. You go through each of these problems and then each of these data sets. If you can come up with an idea that I want to churn this way, I would like to assist you by providing hardware as well as advices onto that. Okay. So please feel free to look at the big data sets and also come up with the problems. Okay. And come up with an idea, come up with a big data insight or or some other, basically say looking at the geographical data, okay, and come up with a problem you want to solve. Okay. Okay. When you look at a lot of data, you will yourself come up with the basically hey, can we do this kind of analysis? What if we could do just simple this sort of thing on all the geographical data? Okay. So feel free to go through it and then let me know. Okay. So that's pretty much from for today. And so you set up your locally as well so that you can basically have a backup. Right now I'm trying my best to get all of these servers up. Okay. Because at this moment I'm at the stage where I need professionals to fix these problems. Okay. So I've hired somebody from my previous companies. Okay. Who will be helping me with these things. Okay. So I'm trying to set it up the servers properly, but uh, but uh, but you should also have one of your instance running in the virtual machine. Okay. All right. So go through these three problems which I have told. Import data back and forth from MySQL to Hive, the first example which we ran through. Create your own example. And then build an Uzi job for the fourth problem of our assignment of second session. That was the voting problem, where we vote the richest was getting the more rights to vote. I mean, the richest vote was contributing more. Okay. And third one is go through these public data sets. If you can come up with an interesting way. Okay. Oh, is it called Roman voting? Oh, nice. I'll find out about Roman voting. Okay. Okay. Great, great. Okay, guys, good night. Then it's pretty late for Suksavat and other people also. So we'll meet next weekend, next Saturday again. Okay. I will take up three example for Mahat. Okay. Bye, Shashank. Bye bye, Anto. Good night. Good night, Gaurav. Good night, Kalyan. Good night, Bhagwat. Good night, Hari.